ADC. Now let us take a look. What do I need for this programming? What are the steps? So these are the steps that I have listed that I need to do. So step one is a general step regarding this port configuration. So I need to connect whenever I want to do analog to digital conversion, then I need to take a signal uh, as an analog input. So I need to configure at the beginning about this port. So configuration indicates that I need to set this pin of that port as an input port. So that is what we usually do for all the programming. And now I have to go to this project and I have to take a look which pin I will be using for analog input. So for this analog programming, what we will be using, we will be using this variable resistor as analog source. So this variable resistor is connected between 5 volt and 0 volt. So 0 to 5, this voltage variation will be converted into digital output. And I have connected this port, the variable terminal is connected to R naught, RA naught. So that means a port I am using as the input of my analog signal. And that we need to configure. So we have to just write down here that first bit that we will be doing is the port configuration. So I will write in capital port configuration for analog. So analog input. So I will be using this port as an analog input. So first thing, whenever we do the port configuration, that will be trace. So trace A, that should be equal to 0x01. So I'm taking input to RA0. So we can just write a comment that setting the pin RA0 as input. So I will be now I need to set this one as an analog. So I will set ancel A, and that should be also 0x01, and we will be just copying this one and we'll be using as a comment, and this one would be commented as setting the pin RA0 as analog. Okay, that's almost done for the configuration. One more thing, we need to make sure that we are initializing all these pins as 0. So no noise has been already um, assigned to this or added to this. Set the level to high. So I am writing this command port A, that should be equal to 0x00. So that would be setting. So the comment is setting all pins all pins to low. That's it. So I have done the configuration of this pin. Now the general configuration I have done. Now the next thing that I need to do, so I need to go here and channel selection. So I need to do a channel selection. There are several channels for the analog input, and I need to make sure that I am selecting the correct channel. So what does it mean actually by channel selection? That will be clear whenever we will take a look of this block diagram. So whenever we take a look of this block diagram, I have a analog to digital module that is available, that is here, and that module can be connected to any of the out input pin, any of the um, analog pin by selecting a particular code of that pin. So each of the analog pin has a particular code, and whenever we configure that code, then it is assumed, it can be considered that that pin will be connected to this analog module through a switch. So selecting a particular code is important, and each of this code is of 5-bit length, and that 5-bit, what would be the value of each of the bit, that we need to configure. And these, all the channel selection bits are available in one of the register, and that register is called the ATCON 0. So analog to digital converter control register, or ADC control register 0. So we will encounter several of these control registers. So these register, these 5 bits will be used for channel selection, and each of the pins that is allowed to take the analog input has a particular channel number and particular code for that channel. Now these are the 5 bits, and each of these bits can be accessed through this name CHS and the number of that bit. So if I want to select the AN3, that means last 3 bit, the MSB 3 bit will be 0, and the LSB 2 bit will be 2 bits will be equal to 1. So that means I can assign these ones by CHS 1 equal to 1 and CHS 0 equal to 1. Now we are working on AN0, this analog channel AN0, and that has a code of 5 zeros. So I will, in my program, I will select this, select the select AN0 channel, 0 analog channel. So how to select? We will set this pin CHS 4 should be equal to 0, 4 equal to 0, and then CHS 3 equal to 0. Then I can copy this 2 and I can paste here, and the last one I can copy one more and I can paste here. Okay, so this is the channel selection. Now I have to change, this will be 2 and this will be 1 and this will be 0, and all of them are 0. So I have done the channel selection. Now after the channel selection, what we need to do, channel selection we have done, enable the analog module. So if you take a look of this module, there is one bit here, AD on, and this bit, if you take a look of description, this bit enable the module, and ADC is enabled. So we have if we take a look of my the analog to digital converter, then we have selected the channel, and that means this channel will be connected to this module. Now this module has to be enabled through a signal that is coming from this register, and we need to set this bit to be 0 with the name. So if we go here, now we have to write enable. What is we have to do? Enable the enable the ADC module. So that we will do by writing AD on is equal to 1. So that is done. So we are almost done the configuration. Now this is the module configuration we have done. Now we have to do the process configuration. That means the sampling frequency, quantization, those things we have to do. So step 4 is starting with the sampling frequency or sampling clock. So we will be doing the next one we'll be doing is setting the sampling clock. Okay, now what we have to do, setting the sampling clock. Now in order to set the sampling clock, we will go to a module, go to a register, control register, that is ADCON 2. So we will go to that ADCON 2, and we will find out 3 of this bit is selecting this clock. So this ADCS, so analog to digital converter clock selection. So we can select any of, we can make choice any of this selection by selecting this 3 bit. Now many of these selection are related with the oscillation frequency, and this one, that means this sampling frequency will derive from the oscillation frequency, and oscillation frequency is mainly from the crystal oscillator, so that will be more accurate than the RC oscillator. But in some application it might be RC oscillator might be good enough to do this sampling. So we have also one internal oscillator that is of RC oscillator, and that is a frequency 600 kilohertz. So we can use that frequency to do this sampling. So that will be done by selecting 0, 1, 1. So that means ADCS 2 will be equal to 0, ADCS 1 will be equal to 1, and ADCS 0 will be equal to 0. So I will just write down here ADCS 2 would be equal to 0, then ADCS 1 would be equal to 1, so I have missed A, and then the last one would be ADCS, so last one would be ADCS 0 should be equal to 1. So I have done the selection of my clock. The next thing I need to do is the